in this lecture, I'm going to cover the solution of non-homogeneous linear differential equation, particular integral format. Phi of x is equal to sin ax or cos ax. First, let us understand the procedure for finding particular integral when the RHS is sin ax or cos ax. So instead of sin ax, we can have sin ax plus b also, or cos ax plus b also. So how to start? We have particular integral generally 1 over f of d pi of x equal to that same 1 over f of d. Phi of x is the given, we have the function sin ax or cos ax. So here we identify the coefficient of x a, then we have to also identify d square in the denominator term. Suppose we have d square replaced by d square by minus a square. Suppose if we have d cube, then we have to take this as d square into d, then we have to replace d square by minus a square, keep d as it is. So in this type you have to change d square by minus a square. So then our result become f of minus a square sin ax or cos ax. This is provided with the denominator not 0. So same like how you are solved in exponential case. Suppose denominator is 0, we have to multiply independent variable x and differentiate the f of d with respect to d. Then we have to replace d square by minus a square. Then what we get? Particular integral yp is equal to multiplying x. So we get x 1 over differentiation of f of d in the denominator f dash d, then into sin ax. Then replacing d by minus a square, we get x into 1 over f dash of d become f dash of minus a square sin ax, provided f dash of minus a square not equal to 0. So following this procedure, let us see some examples how to solve the problems. Here we have the problem, a second order differential equation, y double dash plus 4y dash minus 12 is equal to e power 2x minus 3 sin 2x. So first we solve for complementary function. Every non-homogeneous differential equation contains two parts of solution. One is complementary function, other one is particular integral. We always solve for complementary function first. For that we write auxiliary equation. So that is m square plus 4m minus 12 equal to 0. On solving this auxiliary equation, we get the roots are m is 2 and minus 6. This all procedure you all learnt in previous videos. So directly I am explaining for YC. So main our concentration here for learning how to find YP. YC is equal to, based on the roots we obtained, both are real and unequal. So C1 e power first root 2x plus C2 e power second root minus 6x. Next we'll come to the part YP. Is since we have two different nature function, let us separate accordingly. So first part is e power 2x divided by f of d. We have d square plus 4d minus 12 minus 3 sin 2x divided by f of d, that is d square plus 4d minus 12. Then according to the procedure, exponential having the procedure of replacing, for this we have d by 2. 2 is coefficient of x. Okay. Next we have this, for this we have to take replace d square by minus 2 square. So again 2 is present in a coefficient of x. Okay. Then what we get? If you replace d by 2 here, this become 4 minus 4 plus 8, 12, 12 minus 12. So we get the first part denominator is 0. So we get denominator is 0. So whenever denominator is 0 in both the cases, we multiply by independent variable x. We multiply by independent variable x. So that is x into differentiation of the denominator become 2d plus 4. So differentiation of the denominator become 2d plus 4 and e power 2x keeping as it is. Next we have minus 3 sin 2x, denominator replacing as minus 4. Minus 4 minus 12 become minus 16. So when you take 4 common out, minus 4 common out, we have it's a minus 16 plus 4d, no, 4 common out, d minus 4 it become. So then in the next stage we replace here d by 2, again replacing d by 2 here. Now we get 2 into 2 4 plus 4 8. So this is completed, but to continue the procedure we have still d term in the denominator. So we want d square because this is a trigonometric function according to the procedure. For that purpose we rationalize. So we have d minus 4 no. So let us multiply and divide by d plus 4. Therefore it becomes in the next step. So d plus 4 3 d plus 4 sin 2x divided by 4. This is a minus b into a plus b format. D square minus 4 square, it's a 16. Now you can replace that d square by minus 2 square, it is minus 4. Okay, next. So when you replace d square by first part it is keeping as it is. Next we concentrate on second part, still d is there no, 3, and in the numerator we have d plus 4. D nothing but differential operator d by dx. D means d by dx means d by dx of sin 2x is 2 cos 2x. Next we take plus 4 multiplied by sin 2x, that is 4 sin 2x. Next in the denominator we have d square. D square is replacing as minus 4. That minus 4 in minus 16 become minus 20. Minus 20 into 4, it's a minus 80. Then later this minus gets cancelled. You can write it as plus 3 divided by 80. So finally we write the general solution y equal to yc plus yp. So just we substitute for yc obtained and substitute for yp obtained. So this is the final result of our problem. We solved another important problem here. Having RHS is trigonometric but not our required format. Sometimes even in the exam you have to take care of this type. They may give sin square x, cos square x, sin cube, cos cube, and a product of true trigonometric function like sin x into cos 2x, cos 2x into sin x. In that way they may give. So we can't apply direct procedure of particular integral replacing d square by minus a square. So therefore we have to use some identities in this type of problems. First anyhow we solve for complementary function. So let us solve the given problem by writing the symbolic form d square plus 4 y equal to sin square x can be written as 1 plus 1 minus cos 2x divided by 2. And the auxiliary equation is m square plus 4 equal to 0. From this you come to know m is plus r minus 2i. Therefore, the yc part is c1 cos 2x plus c2 sin 2x. So now we solve for particular integral, concentrating on simplified part what we have in RHS. We can take overall 1 by 2 common. So 1 by f of d, that is d square plus 4, and the first function we have here 1. That 1 can be written as 1 into e power 0x. So you learnt in the previous video how it is. Next, minus 1 over d square plus 4 into what we have, the other function cos 2x. Next, we go for changing d by 0 because it's an exponential, and d square by minus 4 because it's a trigonometric function, minus 2 square. So if you replace d square by 0, we get 1 by 2. So 1 by 4 e power 0x is 1. But when you replace d square by minus 4, here we get denominator 0. Therefore, we need to multiply independent variable x and differentiate the term f of d with respect to d, that is 2d, and cos 2x taking as it is. Next, we can multiply and divide by d, or you can go for direct integration. So I'll show how to multiply and divide by d, and it takes the procedure. So if you multiply d and d here, so this become d square. Again we take d square by minus 4. So then we get in the denominator it's a minus 4, and in the numerator we have d into cos 2x. d into cos 2x nothing but differentiation. d means d is d by dx. Therefore, differentiation of cos 2x is what? Minus 2 sin 2x. So finally on simplified, yp we get 1 by 2, 1 by 4 minus 2 gets cancelled. We get x by 4 sin 2x. Or you can take 4 common out. It is 1 by 8, 1 minus x cos 2x. So finally we write the general solution, that is y equal to yc plus yp. Substituting yc is c1 cos 2x plus c2 sin 2x, and yt we obtained is a plus 1 by 8 of 1 minus x cos 2x. So you concentrate on RHS what is given and see that any identity formula applied, then we go for solving the particular integral.